We'll be doing a few questions on waves, particularly using the formulas to calculate frequency, time period, and wave speed. We will also be calculating distance, time, and speed of waves using echoes, the principle of the reflection of sound waves. I have a few questions up top which I will actually leave you to answer, so you can research those. I'll be doing the questions that require calculation. So which questions will we leave out? Let me point those out. So let me see. What is the name of the distance from peak to peak of a wave? I'll leave that one out. What is the unit for time period? I'll leave that one out also. So let's get into it. The first question says, what is the time period of a 40 Hertz wave? What is the period of a 40 Hertz wave? So let's work that one out now. So we have a 40 Hertz wave and we need to find its period. So 40 Hertz would be its frequency. So we know F is equal to 40 Hertz. We want to find big T, its time period. If we recall, we know that time period is inversely proportional to frequency. So T is equal to 1 over F. That is, time period is inversely proportional to frequency. So let's quickly find what the time period is equal to, then move on to our other question. This would be equal to approximately 0.025 seconds. You could even round this to be approximately 0.03 seconds. Alright, that's that. Let's move on to the next question. It says, what is the frequency of a wave with a time period of 0.08 seconds? What is the frequency of a wave? So the time period is 0.08 seconds. We need to find its frequency. If we recall, frequency is inversely proportional to time period. Therefore, the frequency would be equal to 1 over the time period. Let's quickly work that again. Frequency is equal to 1 over 0.08 seconds. And that should give us 12.5 Hertz. Let me change the color of this ink. The next question says, what is the wave speed of a 1000 Hertz wave with a wavelength of 0.04 meters? So here we have two qualities of the wave given. We have its frequency, which is equal to 1000 Hertz, and we have its wavelength, which is 0.04 meters, and we are finding its speed. So we need a formula that can actually be used to reconcile or combine all the information that we have. Which formula is that? I know you know the formula. It is V is equal to F lambda. So let's go ahead. This means that the speed of the wave is equal to its frequency multiplied by its wavelength. So let's go. 1000 times 0.04 should give us what? 40. So this wave is traveling 40 meters per second. The questions get more interesting as we go down. This one says, a boat at sea bobs up and down as waves pass. The vertical distance between the crest and trough is 62 centimeters and 20 waves pass the boat in 30 seconds. What is the amplitude of the waves? So we have a lot of information here. First, we get the vertical distance between the crest and the trough. So I'm going to draw on the screen right now what we have right here. So let's go. If this is our wave, we have a crest right here. That's a peak. Let me set that properly. The peak right there would be the crest, that positive peak, and the trough would be this peak below, that negative one, negative maximum. The distance between the crest and the trough, change the ink color. The distance between the crest and the trough is said to be 62 centimeters. 62 cm. And they give us more information. It says that the wave, 20 waves pass the boat in 30 seconds. What is the amplitude? So we won't need that second part of the information to find its amplitude. We can use this diagram now to derive its amplitude. So if there is 62 centimeters between the crest and the trough, we know the amplitude would be half of this, as the amplitude is from the mean position to a maximum displacement. So we can either go from the mean position to the crest or from the mean position to the trough. The mean position would sit at the halfway mark. So the distance between the mean position and the crest here would be half of the 62 centimeters, which would be 31 centimeters. You might see the answers or options on a paper given in meters instead of centimeters. So 31 centimeters would be 0.31 meters. That would be your amplitude. Now we would have 31 centimeters from the mean position to the crest and 31 centimeters from the mean position to the trough. You add those two 31s together and you will get 62, which is the total distance from crest to trough. Just a reminder. The other question says, a boat at sea bobs up and down as waves pass. The vertical distance between the crest and trough is 52 centimeters and 20 waves pass the boat in 10 seconds. What is the frequency of the waves? Let's write down what we have. 20 waves in 10 seconds. 20 waves, 10 seconds. So let's go. The total time we're working with is 10 seconds. The amount of waves or cycles, we can call them cycles, right? Cycles, 20. And they want us to find the frequency F. we know that frequency is equal to what? The amount of waves that pass per second. And frequency also has another formula, which is cycles over the total time, and we can put TOT time, total time. So let's calculate the frequency right here. What we're calculating